R.5 rational expressions. So rational expressions are just a polynomial divided by a polynomial, and where our denominator cannot be 0, and we're going to use that fact that our denominator can't be 0 in order to find out what makes it 0, so that we can state our domain, what we can plug in for x and get an answer out. So there's certain x's that we can't plug in, because when we do plug them in, specifically in the denominator, our denominator becomes 0 and we can't divide by 0. So that makes a restriction and limits our domain. So here's some examples of some rational expressions. We have a degree 1 on top and degree 1 on bottom. And so our restrictions here would be what would make what value of x cannot be in the bottom. Well, that'd be 1, because when I take 1 minus 1, I get 0. And so I can't divide by 0. So my domain, that's my restriction, is 1. My domain is from negative infinity up until 1, but it can't be 1, so I use parentheses. And then I can have anything after that. So I can go from 1 to infinity. And then I say I join these together with a union. This one, a little bit different. I can go ahead and simplify this. X squared, difference of 2 squares, so I get x minus 2 and an x plus 2. And then I can set each of these equal to 0. Or I could have added 4 and took the square root of both sides and got plus or minus 2. But you can see from here as well, x cannot be positive 2 on the first binomial and negative 2 on the second binomial. And so it's everything but those two. So my domain would go from negative infinity up until negative 2, but it can't be negative 2. And then it goes from negative 2 up until 2, everything in between there, but it can't be 2. And then it goes from positive 2 up to infinity. And then I just join those all together with the union. And so those are my domains of those. So what we want to do is we want to factor the top and factor the bottom. Set the bottom equal to 0, find your domain, and then simplify if you can. So that's going to be the process of rationalizing, or not rationalizing, sorry, dealing with rational expressions and simplifying them. Okay, so here we go. Here's an example. We want to find out what makes expression undefined. That same kind of thing as finding those restrictions or labeling the domain. So again, I don't care about the top, because I can take 0 divided by any number I want to, unless it's 0. So I can take any number divided by, or 0 divided by any number, and I just get 0, right? But I can't flip it. This is undefined. So that's why I set this bottom equal to 0, and I go ahead and solve. So this one's a quadratic, so that's why I'm going to factor. What are the factors of 6 that add up to 5? That'd be a 2, and that'd be a 3. And then I just set each of those equal to 0. So x cannot be negative 2, and x cannot be negative 3. So those are my restrictions. So those negative 2 and negative 3 is what make the expression undefined. Okay, here we are simplifying. So when we're simplifying, same kind of thing. We factor both the top and factor both the bottom, and then we cancel common factors. So out of the top, that's a 7x. And so out of the top, we can do cab. So we get negative 8. What are the factors of negative 8 that add up to 7? Well, that's a positive 8 and a negative 1. And so I'll just do the top here. So we have 8, negative 1, x plus 8, x minus 1, and then we divide by our a, which is 2. Why I didn't divide by my a last time on the last example is because my a was 1, and divided by 1 is not going to change anything. So this simplifies. That divides evenly into 4. So x plus 4. This can't simplify, so I move the 2 in front of the x. So that's simplified. And now I simplify the bottom. I factor. Look at both of these terms, see what I can factor out. Factor out a 5 and an x. So I take out a 5 and an x. And now I have x plus 4. And then, so now this is multiplication here. And now right down here is also multiplication. That's why I want to do it, because now I can cancel. Over addition and over subtraction, I can't just cancel the x's. I have to have multiplication in order to cancel. So now I can cancel. So now we can cancel those. And so my simplified form is 2x minus 1 over 5x. Again, I can't cancel those x's because I have subtraction here. Now, x. And now you want to state your domain. So, and I probably should actually state my domain in the very first part, which is I set my denominator equals 0. So 5x times 4x plus x plus 4 equals 0. So that means 5x is equal to 0. So x is equal to 0. So that's one restriction on my domain. So my domain restrictions, that's spelled wrong, but I don't care, is x equals 0. So x cannot be 0, right? And then I set x plus 4 equals 0, and I get x cannot equal negative 4 as well. So those are my restrictions. What you'll see is there's a little bit difference here. When I plug in 0 into my simplified one, I have 0 on bottom. But if I plug in negative 4 into my simplified one, that's okay. So these are still kind of my restrictions. But what happens here is my graph might look something maybe like this, and say, like this. But what happens here at negative 4, I have a hole in my graph. I have my hole in my graph right there, and then maybe when I plug in negative 4 into the simplified, I get some value. So I might have a dot up here or something like that. But in my graph, I have a hole right there. And so that's what that does. That's what that canceling does. It leaves a hole at this x value. Okay, here's another example. We can factor 3 out. So we get 2 minus x. And on bottom, we factor that. It's x plus 2 and x minus 2. So these are not the same. We can set our denominator equals 0 right now. That's probably the best time. So our restrictions, x cannot be negative 2 and 2. And then if I divide, actually, instead of by positive 3, if I divide it by negative 3, that would make a negative 2 and a positive x. Well, that's the same thing as this one. So then I can cancel those, and I get negative 3 over x plus 2. So that's my simplified form. And here are my restrictions. But at x equals positive 2 is actually, there's actually a hole in my graph at that point. Because now I can actually plug into, I couldn't plug in the original one, but now I can plug in the simplified one. And so that means that there's a hole at 2, where at negative 2 there's a vertical asymptote. I really can't plug in negative 2. Okay, let's get to multiplying and dividing. So remember, when we're multiplying, factors that we can cross cancel, and that when we do multiply, we can multiply straight across. So I can cancel top and top, and I can also cross cancel, right? Like that. So 2 p's on bottom will cancel with those 2 p's on top. So I get p to the third on top, and then I can also take and reduce, cross cancel 3 and 9, leaves me with 3. I can cancel 4 and 12, which leaves me with 3, and then I have 3 over 3, so I can cancel those. So really I just get p to the third as a simplified form. Now that's pretty easy, right? But these ones are a little more complicated, of course. Have to complicate it. So we can factor the top. That's what we always do with all of these, is factor whenever we can, because they're both quadratic. So we already did this before. And on bottom, we get 12 into negative 7, so that's a negative 4 and a negative 3. And so here we see we can't cancel anything because there's nothing alike here. So we can't cancel anything, so we just label our restrictions. So x cannot be a 4 and x cannot be a 3. Okay, so here's in division 1. You could try this anytime. You can pause these and try them. But remember, when we're dividing by fractions, that we can flip it and we can multiply. So really, I can just flip this thing, 10p squared over 6p, and now it's multiplication. And so, and then we can cross cancel, right? The p squareds, you can cancel. The p and the cube you can cancel. So that's now squared. Now I can cancel. What can I cancel? I can cancel the 6 by 3 with the 15 and get 5. So then I have 5 times 10 is 50. 50 over 18. So I can reduce that. And I just have p squared on top. I can reduce that 25 over 9, p squared. So I think I just did that right. 6 and 9, that cancels 3. 2 and 3, 10, and I got 5 and 25. Yeah, 25. 25 over 9. Yep. Okay, we're good. So then here's another one. So here again, dividing, I can change that to multiplication if I just flip the second fraction. A squared minus a minus 20 over a squared minus 9. So now that thing's done. Might as well just delete that, right? Get rid of that. Now it's just multiplication. So now, again, when I do this, I want to factor everything. So I can factor out a 4 here, so I get a plus 3. I can factor, is that a plus? I think that's a plus there. I think that's a plus. Factor out a 2, so we get a plus 5. And over here we can factor, we get a minus 5 and a minus 4. So maybe that was a negative. Right, so then I can cancel. Here's an a plus 3 and an a minus 3. Oh, I bet you this is actually a minus. I bet you it's a minus. So then this is a minus. Because then we can cross cancel a minus 5. Oh, and this should be a plus 4. And a minus 5, we cancel those, and a plus 3 and an a plus 3. And that's all we can cancel, right? Because these are not the same. You can't cancel the a's. I have to cancel same factors. So on top we have a 4 and an a plus 4. And on bottom we have a 2. So we could actually reduce that, right? So that'd be just 2 on top. And an a minus 3. And then again, my restrictions should be my denominators. So here is 5. I can't use 5. So x cannot equal 5. X cannot equal negative 3, and x cannot equal positive 3. But when we reduce them, we just can't use a positive 3. So all this negative 3 and 5 would be holes. There'd be holes in the graph at those two. But those would be our kind of restrictions. Okay, so this looks kind of scary, but really it's kind of the same thing as before. I can take this and just cancel that, right? And just I could rewrite that as divided by n plus 1 over n plus 3. It just looks complicated. And then I can rewrite that into multiplication, right? By just flipping these two. So then that would just be multiplied by n plus 3 over n plus 1. So now I can just get rid of this, right? Get rid of that. And multiply. So again, I'm factoring, so I just want to get rid of this. And I can just factor this bottom to n plus 6, n plus 8, and n plus 3. And now I can look to cancel, cross cancel. I cancel the n plus 3s, because now this is multiplication. That's why I can cancel like that. And then no n plus 1s. So then I have n minus 6 on bottom, and an n plus 8 times an n plus 1. Label my restrictions before I canceled, so n cannot be negative 8, and n cannot be negative 3, and from this one, n cannot be negative 1. But really this one, because it canceled, this one's actually a hole in the graph. Okay, so this one you could try on your own if you want to. Actually, well, you can try on your own. And if you do it, that's great. That's amazing. But here we do have an addition right there. So that's kind of a problem. So first we would need to join these together. Well, that's one way to do it, is to join these together first. So a common denominator. And so then we get 1 plus 3x over a common denominator x. Okay, now you can go ahead and try to do it, right? So would you be dividing by this? Oh, we'd actually be multiplying by that, right? So if I just flip that fraction, I can just multiply. So I'll skip that, writing down that division one. So now this is all gone. So now I just got this, and now I can factor. Can't factor anything out of the top, can't factor anything out of the bottom. So we just multiply 4x times x plus 3 and a 1 plus 3x. And then we can state our domain, which is x cannot be negative 3. And how am I doing that? Well, I'm just setting this equal to 0, subtracting 3, subtracting 3. Set equal to 0, minus 1, divide by 3. So negative 1/3. So x cannot be negative 1/3 as well. So that's kind of how you do those more complicated ones. If you have multiple fractions, you just join them together. and then you go ahead and when you divide, you flip your fraction and you multiply. And that leads us to adding, subtracting, right? Adding, subtracting fractions. So again, basic fractions, we have to have a common denominator, right? So sometimes we just multiply by the other denominator, top and bottom, right? So then we get 15 over 20. Now we have a common denominator of 20. Now we can just add the tops and we get 19, so 19 over 20. Same thing is true here. I want to find the factors of my denominators and then just multiply by the other denominator. So I can just multiply these two together, and that would be my common denominator. Or sometimes it's a little quicker by, so instead of finding this, we might just maybe find a common denominator, which the smallest is 19, so it can't be reduced. But say if I had like 3/4 plus say 1/2, right? So this one I could do 8 as a denominator, but that's not the least common multiple or common denominator. So it would be 4, right? So then all I'd have to do is just change this fraction. So the same thing's here. So how you do that is just break it down into its factors. So you say what times what is 9? That's 3 and 3. What times what is x squared? That's x and x. So those are all my factors of that denominator. This one would be 2 and 3 and just plain x, right? So then I just list which ones are common, right? So they both have a 3, so there's 1, 3. So both these denominators need a 3. And then this one has 2 x's, right? So they both have an x, so they both need an x. Okay, now the thing is, this one has some extra. It has an extra 3 and an extra x. So this only has 1 x. So this one on the right side needs another x. So I need to multiply that by another x. And it also is missing a second 3. So I need to multiply it by another 3 as well. And then the one on the right, or sorry, the one on the right, yeah, the one on the right has a 2, and this one on the left does not have a 2. So this one I need to multiply by 2. So then it'll have 2 x's, each will have 2 x's, and each will have 2 3's, because this one has 2 3's, and then they will also have another 2. That might have just been confusing to you probably. So, but I just have to have the same factor. So 3, 3, x and x, and this has 2, 3, x and x, and just 1 x. So this other one just needs another x. And this one, it doesn't have a 2, so I need a 2 on this. And the one on the right doesn't have another 3, so it needs 2 3's. So it has to have all the same. So see, they both have 2, both have 3 3's, and both have 2 x's. It's kind of like a union, join them together. So this one I need to multiply top and bottom by 2. So I get 10 over 9, and by 2 on bottom would be 18. 18x squared. This one I just need to multiply by x and 3 on bottom. So that's a 3x. And on bottom I'm going to get 18x squared. Okay, now I can go ahead and add the tops. So I get 10 plus 3x. And these ones, if you do it this way, you won't be able to reduce, right? But if I multiplied bottom and bottom, then I would go ahead and have to reduce. But this one I don't have to reduce because I found the least common multiple. So you can do it that way, or you can just multiply these two bottoms, and then you can multiply top and bottom, kind of like the long way of the normal fraction. Okay, so here we go. A couple more here. So here I look at my factors at the bottom. So these are the factors of these two and these factors. So the union of this, so just think about the union of these 4 here. If I join these, the union would be this. That's an x plus 2. So really the union is the denominator here. And now what's the one on the right missing? Well, it's missing an x minus 1 and an x plus 2. So I got to multiply top and bottom by that, which is not bad because I'm just really multiplying by 1, so that's not going to change that one. So I'll keep these kind of separate. So here's the numerator of the right one is an x minus 1 times x plus 2. The one on the right is a little more complicated because we have 3 here. So this one is missing an x plus 3 and an x minus 4, so I got to do that on top. So we could just multiply all that together, just put that 3 on the outside like this. That would be fine for now. Okay, so that's the top, and now we're going to minus the bottom. Or, sorry, minus the top. So we got our numerators. And now we can go ahead, we can FOIL that out and combine like terms, basically. So we FOIL that out and we get x squared minus x minus 12, and this one is an x squared plus x minus 2. This has a negative. I need to distribute a 3 on this one. So you might be confused why I do that. 3 on this one, there you go. And then it has that common denominator. I do not FOIL, don't FOIL the bottom. So distribute that 3x squared minus 3x minus 36 minus x squared minus x plus 2. I distributed the negative. That's what happened there. Now I combine like terms. Remember that denominator is the same. I'm not going to write it again because I'm kind of lazy sometimes. So 2x squared minus 4x minus 34 all over that common denominator. That I'm not going to FOIL out because I'm too lazy. And I don't really need to. And it helps me find my restrictions, which is a 1 and a negative 2 and a negative 3. I'm just setting my denominators equal to 0. And solving. There's my restrictions, what x cannot be, and there's your answer. Yay, great, wonderful. One more, that might be a quiz problem. So you had to wait all that long, 22 minutes. That's not including any time that you pause the video. Yay! So what do I do on this? I'm dividing. Well, I don't like division, I like multiplication, so I go ahead and flip my fraction here. Plus 10m plus 24, and on bottom I do m squared plus 5m plus 6, yay, and then I factor everything that I see, and then I'm going to do it down here, m plus 2, m plus 1, that's this one right here. I'll do a different color for this one, yay, hip hip hooray, it's getting late and I want to go home. But I just got to keep on working because you guys need this video. Yay! And I factor this top one. Better switch my color. Can you even see yellow? I don't know. And 6. And something or other. I don't remember. Probably 4. 6 plus 4 is 10. Yay! Easy addition. M plus 2. M plus 3. Yeah, this is probably annoying by now. Yay. It's just a little payback. Cancel, cross cancel. 2's gone. This one, I'm not going to have you write your domain on this one, just because I don't really want to. And I don't want you to have to do it in class when you're doing your quiz, if you're doing this one as a quiz. So if you're doing this as a quiz, I don't want you to do the whole thing. I just want you to write down the answer. Just like that. Yay, beautiful. Yeah. Done. Hey, at least it's under 30 minutes. Come on now.